Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by Techstrong. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting panel ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live webinar today. If you have any questions for our panel members, we want you to send those in using the Q&A tab on the right side of your screen. And for any other comments or anything you want to add to our conversation, maybe just let us know from where you're tuning in. We want you to use the chat tab. Finally, at the conclusion of this panel, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is surveying the AppSec landscape, and I'm joined today by Scott Gerlach, co-founder and chief security officer at StackHawk, Kyle Suero, senior security advocate at Sneak, Stephen Walters, field CTO for CEM Digital, X Matters, and Everbridge Company, Matt Rose, chief architect at Bionic, and leading our discussion today, we have Mike Vizard, chief content officer here at Techstrong Group. So everyone, thank you all so much for being here with me today. Mike, I'm going to let you take it from here.
All right, thanks, Cody. Let's jump right into it. We're going to start with Scott. And the first question is, level set us a bit, if you would, in terms of what makes application security a challenge today. We've been deploying applications, I would argue, for the better part of half a century now. So what's changing out there in terms of the landscape, and what's making application security more difficult today than it might have been even 5-6 years ago?
That's a great question. Thanks, Mike. Thanks for having me. I don't think it's more difficult. I think it's the same difficult. I think we build more and more apps, and as we're putting more APIs and more software on the internet to enable, digital commerce in whatever form that is taking, it just seems like it's a larger ball to keep up with as it's rolling downhill. And I think the big problem with application security is the security industry, this tools, process, people, or just making it hard. We're like roadblocking ourselves into, oh wow, no one wants to do this. And what we've done actually is we've made it too hard for people to want to participate, or too hard for people to want to know about application security by making them learn application security, making them learn, like, developers' job is to develop code, and making it easy for them to consume application security information is what we have to get better at. And that's probably the biggest why is it hard challenge today.
Stephen, do you agree with that? Because it almost sounds like we're our own worst enemies now.
I absolutely agree. There's an interesting twist that I would put in there, which is that why is it potentially viewed harder today? And that's probably because it's more tempting to your average criminal in terms of what they want. I mean, last 2 years, it's not just us that have been stuck inside, it's the criminals themselves. They can hardly break into your house anymore. They need to find an alternative income. And, it shows in the stats in the national crime statistics in many countries of the world, including here in the UK, the massive rise that there has been in cybercrime, and the need, therefore, to meet that with relevant application security. So I think it's not necessarily that it's harder, but I think there's definitely more focus on application security. It's the burden on developers, on security people, anybody within the IT industry to ensure that there is application security in place. It's that there's an intense lens on those people now to ensure that they're actually delivering. And I agree with Scott that's putting sometimes quite an unfair focus on many developers who are there to code at the end of the day. So how we implement application security as much as it is as important as actually doing it for some, but I'm sure my peers here will chip in with some of that later on in the discussion.
Kyle, do you agree with that in the sense that are the bad guys moving up the stack, as it were, and has the nature of the attacks changed where they are focused more on the application layer, and most of our defenses, I would think, are still aimed at the network perimeter?
Yeah, I'd say everything that we can possibly think of is being tried and tested anyway to misuse, abuse, or manipulate a program. So, we will never see less vulnerabilities and less ways to exploit software, right? It's always going to be more. It's always going to grow. Based on some research we've done, we've seen a prolific increase, right, in the number of both packages that folks are using, and a decrease in the amount of code that's written overall, and in applications. And what that means is we're relying more on dependencies, right, third parties, the knowledge of others, right, the knowledge and skill sets of others, so that we're not necessarily reinventing the wheel, so to speak. So I think, yeah, as that tends to happen, and some of these popular libraries and frameworks and solutions to these things that are open source and we depend on, become more tried and tested and misused and abused, and people start to understand the parameters of functionality of all these things. It's just going to make security harder, and it's just the landscape, right? The threat landscape's ever evolving. So I hope that sort of answers that question. But I think it's a great question.
Well, Matt, sorry, Matt, this is basically in your wheelhouse here, but has the way we build applications changed, to Kyle's point, where we are relying more on these components and maybe we trust them too much and we're not thinking through what are the vulnerabilities that exist in those components? Because it used to be maybe people wrote more procedural code themselves, and now we're kind of hanging out on the back end of hoping somebody else is doing the right thing.
Well, I think there's really two ways to look at this. So one of the things is we've moved on from the monolith type of application that, is released, once every 3 months or something like that. And we moved to aggressive CI/CD pipelines with microservices architectures, with cloud native. And a lot of times people are only working on their piece of code. They're working on their specific responsibility, but not how it interacts with the rest of the application ecosystem. So really testing an application as a whole entity is something that I think we've gotten away from. We're more focused on looking at the open source packages or the connections to the APIs or just the homegrown code that you write within your development organization. Testing a complete application and all the data flows, all the kind of connections and interactions between everything is something I think we're getting away from, and is making it very hard because the expertise only kind of resides within the group itself. And then once it starts to get multi kind of chained together, then we're starting to really miss things and miss the complexity. And talking about, one of the things that Scott said in the beginning is, do you guys agree that as soon as something has a security moniker on it, everybody freaks out? A bug is a bug is a bug, whether it's a configuration bug, a functional bug. As soon as you call it a security bug, everybody freaks out. Everybody's very confident and comfortable fixing configuration or functionality issues. But once you call it security, they start to freak out about, this is a different process. It's the same process. It's just a different lens or a different type of vulnerability you need to fix. Do you guys agree with that?
Yeah. Absolutely agree with it. I've long been a proponent for many decades now that I hated the term non-functional requirement, which is something that security fell under. So security is not functional. I don't believe that per se. It's an important part of any system, and it's an important value as well of any business. Every business has to declare security is a primary value. We all have some sort of trust site. We all have to go through security questionnaires when we're dealing with customers, and it's important that information comes across, and it's an important function of the application and the system, just as you mentioned the configurations are, and so on. They are all functions of the system. Yeah, it gets a bit scary, probably because of the punitive measures that come out from any kind of issue as a result of a security attack. That tends to get businesses on edge, especially when you're dealing with huge requirement issues or government penalties that come through as a result of breaching data prevention laws and so on. So, yeah, I do. I totally agree.
So if I heard that correctly, basically a misconfiguration is a bug until a cyber criminal discovers it, and then it's something more than a bug.
Yeah, I mean, a silly example is, an unreleased resource. So you have a connection to your database. The database connection is left open. Is that a functional bug? Because you're supposed to close your database connections explicitly. But is that a security bug? Because now you have an open connection to the database. It's like, how do you actually put a lens on it, whether it's a functional or configuration issue or security issue? They're all bugs. They all need to be fixed because the application being up, available, and functioning as expected is the goal of any organization. That's what I believe anyway.
Kyle,
Yeah,
let me ask you something about that. So we talk about security as though it is distinct from application quality, but at the end of the day, or is application quality and security just two sides of the same coin? And instead of having separate gates, do we need to put them together in a more cohesive way during the DevOps process?
definitely. I'd love to say one thing about the last point. I think that when something is perceived as a security bug, or when a software deficit can be interpreted through the lens of security, I think the liability is different. I think that's often what scares people, or makes people hesitant, or makes that chilling effect of like engaging with security, because there is this like implied liability in most cases. So as far as software development goes, from what I've seen, as software development becomes more ship it and go, right? Like sort of, we can put a new build out there in 5 minutes instead of, we're releasing builds quarterly, or however, companies decide to do it, right? So I know some companies still do it quarterly, some, who have certain standards, right? Or held to certain, what would you call it? Like, the 3 nines or whatever it may be. So some folks are definitely pushing things out, slower. But I think as we see DevOps really ingrained into the software development process, like the DevOps revolution has kind of allowed tooling to like work its way in, and essentially, we're talking about like configuration changes and network changes, like all of that is now possible with a single code push, right? So a single file being changed, a single code push, whether it's a Kubernetes template or a CloudFormation template, you're basically able to do a lot with a little now. And I don't think it's ever been as easy to spin up web service applications, et cetera, and microservices, and maintain a microservice architecture. It's never been easier than it is now, right? So I think, that's going to greatly increase the attack surface, right? People are going to integrate all sorts of things into their software development lifecycle, or not integrate things, right? Like if you're not integrating thorough security testing throughout all stages of your SDLC, but also planning for security, right? Like security can't be an afterthought, as everyone on this panel, I think, has stated. Security can't be an afterthought. You need to work it in from the beginning. Security engineers should be sitting in on your sprint planning if you have, that sort of resources, if you're a huge organization. And you have like 40 agile teams, for example, we were able as a team of like 8 to split up the sprint meetings and like attend them, and, offer our input when people are talking about these new features, right? They might think, okay, we need to add a API key for, this file host. But if you ask them, hey, like, can you delete that? Maybe they haven't thought of that, right? And there's security implications if somebody generates a token and you can never delete it, right? You just put it in and then it's gone, right? And it's little things like that, that I'm sure all of us have seen, where there is good intent and developers are gauged. They're measured on what features they deliver. They're not necessarily measured, to come back to the question, they're not necessarily measured on the security of said features. As shift left happens, as developers do assume more roles in regards to infrastructure and application security, I think that's going to have to change, Mike.
Stephen, we were talking about bugs, and one of our attendees has a question, or at least a comment, about bugs having bugs. And last week we heard about how Amazon created a fix for this quote unquote hot fix for this log4j shell vulnerability, and that in itself needed to be fixed. And of course, the log4 shell vulnerability got fixed several times as well. So do we have a handle on how we apply these fixes and bugs to things? Because it seems like sometimes, every time we fix one little thing, another thing pops up.
Yeah, it actually poses an interesting theoretical question, which is, when is a bug not a bug? Because, the things like the log4j, for example, weren't seen as a bug 4 years ago, 5 years ago. And not all security breaches are necessarily as a result of a bug. They are the result of features that at the time we have implemented. To the best of our knowledge, they were secure. They covered the capabilities that were around or existed at that time. Well, the people who are trying to penetrate our systems, the methods that are being used to penetrate our systems, they develop, they advance. People are constantly probing and trying to find new ways of getting into systems that we've potentially never even considered before. So they're using our own features potentially against us, features that are not necessarily bugs, but features that are there that have existed for a very valid reason as part of our business functionality, our business capability. So it's identifying those vulnerabilities, identifying those exposures, which is just as important as new technologies come along. I mean, let's not forget, these are some very, very clever people who are trying to penetrate our systems. They're not just sitting there randomly hitting a keyboard, hoping that, that they'll suddenly come up with something like the works of Shakespeare. These guys are actually thinking very cleverly about what they do. And sometimes it can be very simplistic methods, phishing scams and so on. Sometimes it is more complex ways of just probing systems and identifying little openings and little vulnerabilities that are within there that aren't necessarily that bug. The art for us as security people, as for those security engineers that are part of a team, is to try and determine the art of the possible. Where are those possible breaches that are in there? And that's why it's important as part of the shift left technique. And I know we're not talking about this, but also on that shift right side of things, where you get red teams who are involved. It's important that those red teams, as they're trying to probe your systems, as they're doing those checks on production systems, they are closely integrated with those development teams to quickly feed back where they've identified a new exposure point or a new vulnerability that nobody's potentially considered before, because tomorrow somebody might.
All right, so Stephen just outlined the Monty Python strategy for application security, where you should expect the unexpected. Is that what you're saying?
Exactly.
Yeah. Well, just a comment on that too is what happens? How do you respond when good frameworks go bad? Is like I like to say, log4j, log4shell, or Spring Shell. How do you respond to that? I mean, do you just go look for every instance of the vulnerable version and just treat everything as exactly the same in terms of risk? Or how do you prioritize with the limited resources and time effectively? You need to look at things and kind of the variables in the equation. Is it, internet facing? Is it touching PII data? Those are the things you should probably fix first before just taking everything at the, same risk level or same lens to basically fix. So instead of just putting them all in a bucket and just working down the list, you have to prioritize. And how do you guys feel the best way to prioritize? I have my opinions, but not all risk is the same when you're looking for the log4shell or Spring Shell or things like that.
Scott, do you think we maybe need a different approach to how we think about IT security incident management as a result of all of this? Because it seems like we have this increasing number of so-called zero-day vulnerabilities where everybody just panics. And if we're going to expect the unexpected, maybe we need to rethink that whole process.
Yeah. I think what we're talking about here is kind of interesting. We're talking about security bugs, not vulnerabilities. We're talking about security teams, not engineering teams. What we're doing is separating all this concern out to an illogical point. We're saying there's a security team. They should be tightly working with and integrated with an engineering team. Hey, guess what? They should probably be on the same team. So they're working together naturally. They have the same outcome, same goal. They're not part of the security team who has a whole different thing going on. And if you don't have a security team, say you're a small, medium business, take that burden of, oh man, I gotta hire a CISO who can then go hire application security people so that they can tell us what we're doing wrong and we can ignore them very, very hard. That's silly. And then incident response. Look, the hard fact is, if an attacker wants to breach your company or your system or your network bad enough, it's going to happen. Incident detection and response is really, really important there. But if you have good baselines and you have good process to be able to build software, know about things that are happening, empower your engineers to make decisions, even if they're wrong. I don't care if they're the wrong decision. If you empower them to make decisions, they will make decisions and document them. And that will be much, much better than the space that we're in today, which is no documented decisions. No one's really going, well, the security team takes care of all that stuff. I don't have to worry about it. And then which turns into incident response hell later down the road, because no one understands how these systems work together. And you go, okay, cool. Now we need a security team. Who should we talk to about this? I don't know. I have no idea. because we're not doing security over here in engineering, and you just started, so now it's all you. We're kind of like self-defeating ourselves as security people, going AppSec should work in, and some places do this, right? They have product security teams that work with product, and that's better, but they still don't work for product. They don't work for engineering. They should work in that department, help solve problems for the business.
Matt, I'm going to kick that to you, because a couple of our attendees are pointing at this fact. It says we have a lot of code floating around that's unused. It's in the application, but it's not exactly doing anything. And that in itself increases the attack surface that you need to defend. So how do we need to think about what kind of code we're using and where we're using it with all these different components? Do we need to trim them in ways that we're only using the code we really need?
Yeah, and that's kind of the kind of Frankenstein's monster we have with our applications today. Everyone talks about start with application security from the beginning. Is there really a beginning anymore, or is it this thing that's evolving over and over again? It's getting new branches, joining the main trunk. It's never actually starting from the beginning, and there's a lot of crap that's still existing in these applications. And you're moving so fast in an aggressive CI/CD pipeline, you don't know what's in there. So thinking about understanding the architectural risk of your application and all the pieces in it. A lot of the tooling that you have, static and SAST and DAST and IAST and SCA are all looking for, certain OWASP top 10 types of vulnerabilities. But what about the things that's unique to your application based on unused code or code that's unmanaged and you really don't know what's in there? So having a lens of what's actually in your production environment, I think, is very important. And really understanding the architectural risk. Do I have services that have critical CVEs that are also touching PII data, that are also accessing third-party type of applications? How do you understand that when you're pushing out hundreds, if not thousands of times a day? And really thinking about, okay, let's understand what's in our application in a holistic way, because we can't be secure if we don't know what's in there. And a lot of times people have no idea what is, part of the architecture in your application.
Stephen, does this contribute to the fatigue problem that we see out there? It seems like every time there's a new vulnerability, everybody runs around with their head cut off looking for where they're actually using that, and then developers determine that they're not actually using that, and then the security people scream, "Are you sure? Because I got a spreadsheet here that says it's somewhere." And it's a lot of back and forth, and all the energy is consumed in that rather than making the overall environment more secure.
And that brings us straight back into what is the true nature of DevOps. And one of the first things is the culture that we actually take into this. I saw recently a tweet from Emily Freeman, who wrote DevOps for Dummies, where she quite accurately said, I don't care about instants, they're going to happen. They will always happen. And culturally, so long as we accept that they will always happen, then we're part of the way there. It's having that cultural acceptance that it's going to occur. The moment we don't think that they're going to occur and we think we're living the life of Riley, that's the point when the breach does occur. Everybody goes into a panic. Everybody starts pointing fingers at each other. Everybody's wondering what the hell they're supposed to do. You mentioned about instant security management. It's a key and important to ensure that you have a proper understanding, a proper plan of what to do in the event of a cyber attack. And your development teams are a key and important part of that. It's when that attack occurs, acceptance of the fact that it's going to occur. Think of it this way. If you have a fire in a building, okay, everybody knows what the evacuation plan is. Everybody knows where they're going to gather. Everybody knows what's going to happen, that the fire brigade are going to get called out. People are going to go through the fire exits. Everybody knows what's going to happen. So you do the same thing when it comes to security. You understand that when an attack is going to happen, exactly who is going to be responsible for what. What is your part that you need to play in that? That's why I always find it's useful to have security fire drills. Let's imitate the fact that there's a security attack on the system. Let's see what the response times are. Let's see how people actually react in this. Because every second counts when you're in the middle of that actual attack. It can be the difference between you retaining your data or losing your data. So having a good plan, and when I say plan, that is not planning to the nth detail, because every circumstance is going to change, but being ready for, as we said before, that Monty Python phrase, being ready for the unexpected, but understanding and culturally accepting, we're not 100% perfect. We're not 100% safe. We're probably 99.999% safe, the 5 nines, but somebody is potentially going to expose that 0.001%. So how do we react when that happens? And that's why it's important to have those development teams on board, because those are probably some of your most educated people who can understand exactly what needs to be done to, 1, stop the attack, 2, plug the hole in your attack, and 3, get your services back up and running as quickly as possible.
Kyle, do you think that we are building applications too quickly? Are we having sort of a Ralph Nader moment here where we're unsafe at any speed and we're letting people rip and replace and do all kinds of things without actually looking at what's going into those components?
Yeah, great question. So yeah, I think it's really important to understand the components. I think there are lots of developments as far as software bill of materials and infrastructure bill of materials, right? So very, very new stuff. There's a lot of guidance coming out from like government agencies and thought leaders such as OWASP. So there are lots of folks working on things like that. And I think that's really going to make a change when folks are, for every version of the software they're putting out there, for every instance, they have this top to bottom, right, nuts to bolts sort of depiction of exactly what's in their infrastructure. And when it deviates from that, there is obviously going to be some sort of issue, or there could be the introduction of something that is, unwittingly vulnerable, perhaps. So I think, yeah, as open source, continues to proliferate, as we start to deploy more, which I think like there's probably no way back. There's no way we're going to go back to deploying less applications, fewer instances, etc. As far as the current trends go, right? Who knows? But from what we're seeing currently, it's on the way up. It's still going up. It hasn't stopped. Number of vulnerabilities and packages are going up. Number of packages and ecosystems, like different language ecosystems, are going up. So yeah, I think the speed is probably here to stay. We'll have to be agile. We'll have to be ready to essentially swap out versions, like how we had to do the little fire drill with Log4Shell. I think that's a great example. Folks, they patched the first version, and the second patch came out, and then the third version came out. So I'm sure there are a ton of people who aren't necessarily agile and might not have a microservice architecture, who did a lot of work, a lot of heavy lifting to actually update the first version of Log4Shell and negate the first CVE, and then lo and behold, the second CVE, and then the third. So if people were using applicable languages, multiple instances of it, various versions of it, right, and even Log4j2, which was the subsequent library, there was also a CVE. So yeah, I think it's just very indicative of the way that we're heading and the way that we'll have to adapt. We'll have to be able to, at a glance, get a ton of information about dependencies, about open source. We'll have to understand, the sort of implications of what we're putting into our software by using robust SAST and SCA together. So I think intelligent remediation, intelligent detection, automating remediation, where applicable. I think that's really where we're going to be able to reduce a lot of the friction that's going to come with the increase in both deployment, development, and just the proliferation of vulnerabilities overall.
Matt, it seems to me every time somebody has a conversation about this, they refer to Sbombs. And since you are a resident expert in this space, a lot of people don't use Sbombs, and a big part of the problem is simply the fact that the Sbomb is out of date, roughly about less than 7 days after it was created. So it took 7 months to create the Sbomb, and 7 days later it's out of date. So what should we really expect from Sbombs in terms of how they improve application security, and how do we need to think about that?
Well, Mike, we were thinking right along the same line when Kyle mentioned the Sbomb or the dynamic Sbomb concept. If you're releasing 100 times a day, how is that Sbomb being updated? We need to automate the updating of the Sbomb so we actually know what's being put out there. Even if it's a couple days old and you're doing 100 releases a day, that software bill of materials is much different. So you need to base an automated process on looking at the deployed artifacts themselves, so you know what's in your production environment. So you do an analysis, and this is what my company specializes in, doing analysis of the deployed artifacts, the WAR files, JAR files, DLLs, to reverse engineer that and give you an architectural view, but also a dynamic bill of materials that every time you do a new release through your CD process to your production environment, you're updated. You know, every framework, every library, every database, every data flow within that application, so that bill of materials, when there is a new 0-day type vulnerability, you have a record of truth to go to that's up to date, rather than something that is, you know, a few days and even a few weeks or a few months old. So thinking about the updated bill of materials based on what is in production is paramount to understand risk.
So we shouldn't really put that on the developer to kind of fill out a form to tell people what's in the software, when basically the software has enough metadata and APIs to tell us what's in it, right?
You have the human factor in that. So you're relying on questionnaires from somebody to fill out. They may not know that there's an inheritance of a dependency or something like that, and may blow up the application or leave it vulnerable. So thinking about humans filling out a questionnaire is not accurate. There is prone to error, where the code itself is the code that's being deployed to your production.
Yeah,
There's an important thing here, actually. There's a practical use case of where we've got to think about this. And it also expands on, I'm going to twist things a little bit here. We've been talking a lot about production environments, but it's just as important to ensure non-production environments are secure as well. And I'm going to throw straight into the SolarWinds Orion, what happened there, which was that they had an open source build system where the attackers got into their systems and changed the open source system. So it actually injected malicious code into every build that they did. So in other words, no developer was writing the code in there. Yep. There was no hacker writing the code in there. Their own build system, their own pipeline was writing the code in there, which would open a back door for all of their customers to be able to get in. And that is where then that bill of materials, that if it was from a questionnaire from a developer, they'd have never picked up on that. Never. Because they had no idea that it was being written into there.
Yep.
So this is why it's important to have that capability to compare what it is that you're actually putting out through the outside world versus what has actually been required. What are those differences? Looking for those changes in there that you didn't expect, which is why it's important to treat your CI/CD pipeline, to treat your supply chain as a production system itself, because it's just as important towards your end productivity and your end capability as anything else. Imagine working in, a superstore, a supermarket somewhere, and you can't get deliveries in. Your business is gone. You have to protect the supply chain just as well as you have to protect the store.
Hey, Kyle, there's a lot of people asking hard questions about how sustainable open source software is, especially, Linux is one thing where there's, hundreds of thousands of people working on the code, but there's a lot of little projects. And I think that's what happened with Log4j, is that ultimately there's only a couple of people working on that thing, and they don't have the security expertise, and they might even look at you and say, that's not my job, brother. So is open source software security sustainable, and what needs to change if it isn't?
Yeah, I think that's a great question, Mike. I think open source is sustainable. It depends on how it's done, right? We have basically companies who aren't really being good friends to open source, right? We have lots of companies that take open source projects, use them, aren't necessarily following the licenses or the guidelines, aren't contributing back to the project. They're making enhancements that should be contributed back to the main project. And for internal or for intrinsic reasons, or for because of the sensitivity of what they're doing, or for legalese reasons and et cetera, just they're not set up to support open source, but they're more than ready and willing to reap the benefits of it. So I think as far as the financial situation goes, right, two people, like you said, two people were working on Log4j. People estimate that 90% of popularized open source projects were utilizing Log4j in some capacity, or they had dependencies, transient dependencies that eventually led to Log4j. So it was, it's intrinsic to the ecosystem. It was an extremely prolific package, and therefore, the vulnerability was extremely prolific. There weren't a lot of eyes, just like you said. There weren't security trained eyes on it. Two guys just kind of like doing this in the free time. They weren't getting any compensation. I think somebody, I don't remember the company name. I'd love to give them a shout out now because this is exactly what companies should be doing. But they gave them $15,000 to continue to work on Log4j. So, and that obviously only happened after the Log4 shell CVE, the first one. So I think that's pretty indicative of the problems with open source. I don't think it's necessarily a problem with open source software. The software that people are writing, they're going to be, like we said, everyone's going to get pwned, whether you want to admit it or not. It's just a matter of time, right? So a matter of time, resources, dedication, right? Sometimes capital. But, if you have an adversary, a sufficiently technical adversary, and they're motivated and, it's up to you to stop them, right, really, and detect them and do all the stuff that requires an advanced SOC and, knowledgeable engineers, etc. So, if you have a sufficiently technical adversary, you're going to, suffer that. And I'm surprised, it didn't happen sooner with how prolific this package is and how anyone can just go and look at the source code, such as myself or yourselves, and we can go and, take the battering ram approach and set up an application and figure out eventually a path to exploitation.
All right. So if you want to know the trouble with open source security, find the nearest mirror and we'll go from there, right? All right. Scott, who's in charge of application security? And I'm going to ask this question because I've seen all these surveys my whole life, right? And you look at it and you say, they ask the security people, what's your budget? And the next thing is, what are you spending money on? And it's usually, some form of AV on the endpoint and a firewall, and then maybe intrusion prevention if you're lucky. And then somewhere in that, like less than 10% of budget earmark is like application security. And so is that, a reflection of the problem? Is because we just don't focus enough on application security and we're putting all our money into networking security that is where the budget's being allocated because the people doing it have a bias in that direction.
Yeah. First of all, I want to make a comment. You're unsafe at any speed. You can get your Corvair fixed, Mike. It's okay. You can still drive it around. Second of all, we're terrible at this because application security necessarily needs so much interaction with the development teams. Like you have to work with them to make AppSec work and make spend on AppSec work. Almost everything else in information security or IT security or whatever you want to call it, you can do in a little silo, in a little box as a security team. You can be like, oh, well, just send us the logs and we'll make stuff happen out of that. Oh, so push all this stuff out to the endpoint. We'll make stuff happen with that. Application security is the area where you have to work with another team to make it work. And that's why it gets so underserved, so underspent, so like the whole thing, because the whole team concept is not set up to work with that engineering team or with a product team to be able to say, what problems are we solving? How are we going to solve them? Yes. And let's make sure that those problems don't turn into problems for us. We do it all. We do all of this stuff like, oh, you pushed it to production? Cool. We'll check it. Here's 11 tickets about the thing that you've been working on for 4 months. And now I've screwed up your next sprint. And, that kind of like mentality about how we organize security and engineering teams to be able to provide good pathways to, logically secure, basically secure applications that aren't making huge fundamental mistakes is just not set up. And we're doing it to ourselves as security teams. It's terrible. Like if you step back and look at it, you're like, oh yeah, I definitely did that to myself.
All right, Stephen, how much do you agree with that? I mean, is the issue really technical or is it more cultural at this point? And we are just kind of getting in each other's way to the point where nothing good is happening.
It's both. It's a bit of both. I mean, let's be honest. When budgets are being allocated, and when it comes to security, they're going to go to where it's a case of risk versus benefit, isn't it? It's where is most likely that somebody's going to attack. And let's face it, most attacks come through from somebody getting a phishing email and they click on the wrong link or something like that. So it's more advantageous to a security organization at that point to provide proper training to the end people, because those people, they are the potential breach. However, having said that, you are, far less likely to be suffering a security breach as a result of a direct attack on an application. But the result of that is going to be far more significant. There's going to be a far greater blast radius as a result of an attack on your application, on your security. Because, somebody clicks an incorrect link, you probably just leaked your emails and you've leaked your org, but they've still got a lot of follow-up action to do from that. And if you're a real idiot, you've just completely lost all of your company's data, but unlikely. However, with application security, you are potentially relinquishing control of your entire organization. Somebody is going to get access not just into that system, but into potentially every single system. If they're clever enough to get into the application, they will just use that as the open door to get into everything else that you've got within there as well. They're not just going to say, right, I'm pinching your door. They're going to go after everything that's behind that door as well. So there's a cultural aspect to it there in understanding what that risk issue is, what the level of risk is within there. There is also then that automation side of things, because then where do you spend the money? Where do you spend the budget? There is prevention. Prevention is always better than cure, yes. But as we've said before, we are going to be accepting of the fact that these breaches will occur. And if they do occur, how are we going to manage that successfully? And as we said, is that going to be finger pointing and everybody running around in a panic? Oh, fire, what's gone wrong? No, we've got to do it in a controlled way, and automation has to play its part in that. Automation has to play a part in how the moment we detect that issue with a security monitoring system, if it's malware that's suddenly been identified on a server, let's isolate that server, shut down that service. Right, now we need to engage the appropriate teams to go and investigate what that problem was, because we've got a business service down. Do we roll back and then have a look at where that injection came in from? What was the issue that caused that? What was the vulnerability or the breach? Repair that, get that service back up and running. That's a lot of actions and a lot of activities between a lot of people. Automation has a massive part to play in that.
All right, Steven's making a case for making application security boring, right? Basically, no more drama and just kind of like get it done as a set of processes. Kyle, both Scott and Steven were talking about shifting more interactions, at least left, more collaboration left. Seems to be a debate about how far left. I mean, do the developers take this on inside of their tools, or do we embed this stuff inside the CI/CD platform? I guess it's a question of, do we shift entirely left, or do we just kind of lean a little bit left? What's your best advice?
Sure. Yeah, I think a collaborative approach is obviously a winning approach to security. And I think really it boils down to three things that security can really do to, I think, enable and facilitate the shift left. I think the shift left is essentially based on how strapped security teams usually are, and usually underfunded. Security is not a priority. It's not making money, etc. Developers are making features which make money. Well, let's go with that logic. Let's assume that's true. So let's assume creating these new features is more important than preserving current assets. So more funds will usually go towards development. In that case, security is a necessity. If you're in a large company and they're starting a security team and they don't have anyone, and maybe you have a couple principals or an architect or something, yeah, you'll have to lean a lot on developers to help you, remediate code changes, etc., roll things back. I think, as everyone's been saying, automation is a huge part of it. I think what you can't automate, you should definitely lean on people. You should operationalize in a way where you can have developers sort of engage. So, for example, when I was working across 40 agile teams and I didn't really have a team, it was just myself, I really leaned on the developers. I leaned on the principals, level 4s. I leaned on folks who were interested in security and who had a sort of inclination to security. So I think if you ever find yourself in that situation, bless your soul. I hope you come out of it okay. But the way to just hop in there and start helping 40 teams is really to ask them what they need. And they wanted somebody that they could liaise with on security. I became that person. They trusted me. They came to me. And then eventually, I had a person from every team. Those became my security champions. We made a security champion program. I was able to train, enable, and govern security teams through these folks. Train, enable, and govern development teams through these folks. And we essentially had one on every team, or somebody who was overseeing a couple teams, because they were kind of double dipping and maybe a part of a couple teams. So or they were a manager perhaps. So anyone who was interested, we met like once a month for an hour. I'd make cold brew coffee. It was gone in like 5 minutes. And people, you can kind of motivate people that way too. But the shift left, it is a group effort. AppSec is a team sport, as I like to say. And I think making it fun, making it engaging, making it developer centric, which was really my focus when I was trying to encourage all these people to do extra work, essentially, for no sort of benefit other than security's sake and learning about security and protecting their company. I was really surprised with how many people were just intrinsically motivated by that sort of stuff. I'm sure the cold brew helped, but throw a pizza party if you can't make good coffee. But yeah, I think totally shift left is inevitable. It's just how far do you want to go? How collaborative are you willing to get? Are you willing to take that step back and like train these folks to use all these security tools, or these developer security tools in some cases, and basically enable them to continue, carry on, do their feature development, and then come to you when there's a huge roadblock, or maybe they need an exception to a policy you've laid out. But automate all the things, CI/CD it, everything end to end. Just running a dynamic test at the end and giving somebody 11 new tickets at the end of a sprint, like that's a terrible thing to do. I've been a full stack engineer. I've been a developer. I've done AppSec teams, of course. So I've been on both sides of that, and it's not a good feeling to hand that to somebody, and it's a terrible feeling to be handed that. So I think, test frequently, test often, implement steps all throughout the CI/CD lifecycle. And I think, like Stephen was saying too, it's not enough just to do it to your prod environments, but also dev, pre-prod, staging, etc. And that way you have sort of more developer feedback, and it's in places where developers are already looking, right, if you're embedding it into their tools. So I think shift left is inevitable. Integrate all the things, automate all the things, make it easy for developers, train, enable, and govern, and take a step back. Have a little island vacation, security guy. That's my advice.
Scott, let's come back to that first question real quick as it relates to what Kyle was just saying. Yeah. So again, as we talk about this, what makes all this hard? Because I don't think anybody got out of bed this morning and said, "Yep, I'm going to go build an insecure application." By God, and it sounds like ultimately we need more collaboration, and everybody's kind of familiar with the Barney principle, right? I love you, you love me. We should all be able to get along. So where does this all fall apart?
Yeah, I think what we just talked about in the last question leads to this particular question. Where should this stuff work, right? When we talk about shifting left and shifting and half shifting left, like things only run in CI/CD, you're creating a system that people are going to want to work around, right? So if you think about what happens in CI/CD, almost all of that stuff can happen at a developer's laptop. If you enter a black box, like stick a little black box thing in there that's like, hey, we're going to do some security checks, and you can't know what they are, and you can't see the output, and you can't make decisions based on what happened there, they're going to go, oh, sweet, I'm going to spend like 2 hours undoing this. Like, I'm going to take this out of my build pipeline because I can't recreate what this thing's doing. I have no confidence that what I'm about to commit is going to pass my build, because my linting, my unit, my integration tests, and my functional tests are all passing. But there's this other thing that's in the pipeline that I have no confidence about. When we're talking about giving developers information about security things that they're building in their apps, they have to be able to do it locally. You can't fail a build and then not be able to go, I can recreate that failure locally and expect to have good results. The only thing you're going to do is have pissed off engineers that are looking on how to rip things out of your CI/CD, because you are not serving them. You're serving you. You are at that point serving your PDF factory, your Jira ticket creation count number. You're not serving them. If you try to serve them, give them information they can act on, you will have a much, much better time.
All right, Matt, do you agree with that, or you want to add something there? Sorry, I jumped in on you a little bit earlier.
No, just thinking about it this way. I mean, I'm going to use my my fancy board here. You think about an SDLC. You go Google SDLC. It's linear. There's a left, there's a right. You have a clear delineation. You talk about a DevOps ecosystem. I want to ask the audience, and I always do this, and people maybe heard me speak before. Where is left and right on the DevOps infinity loop or the bow tie? There's something happening at every stage in DevOps. There is no left, there is no beginning. There's just the ecosystem. It's just moving along. So instead of shifting left, I think is very important for remediation, but we're working on things in a constant, fluid motion that security needs to be shifted everywhere. It's not shift left, it's shift everywhere, because this entity is constantly changing as it moves through the cycles of DevOps. SDLC looks linear, like it has a beginning and an end, when DevOps is continuously moving. It's a machine, it's an assembly line that's constantly moving. So I think shift left is important for remediation and helping people understand the risk, but you need to actually have security at every step of the DevOps ecosystem, all the way into production, to understand what is actually running in production.
All right. And for all of those who were asking, how the hell did he just do that? Matt, you want to give them a little insight into how you manage that drawing?
It's a special trade secret. It's a glass board that reverses my image, and I do a lot of podcasts in this. So look up glass board and presentations. So it's just a little trick of the trade that I came upon based on pandemic and not being in front of people every day.
All right, cool. So let me ask you this one more question, Matt. We have had innumerable crises over the last 3 years, say. And every time there is one, everybody says, by God, this is the wake-up call for the industry, and everybody's going to start doing the right thing. And within about, 10 days of the actual event, everybody just kind of rolls over and hits the snooze button again, and we just go back to whatever we were doing before. So is there going to be some moment where there is a constitutional crisis that's going to get us all motivated to fix this? Or is it just going to happen, one little group of DevOps teams at a time?
Yeah, I mean, I've been in the industry a long time, like everybody else on the call, and we still seem to be looking for the same things over and over again. How many people are continuously looking for SQL injection and cross-site scripting? I've been in the industry almost 20 years, and we've been looking for the same type of vulnerabilities. I truly think that an infrastructure attack on, water, electrical, nuclear, when all of a sudden you don't have power due to a hack and it takes down a power grid, I think that's the thing that is going to basically get the most attention. Because again, people just feel that, it's a company, they recover. Everybody says, they're going to go out of business if they're breached. No, all these companies are still in existence after they've had major breaches. But what happens when your day-to-day life is changed? And I think the nation state attacks on infrastructure it hasn't happened. It's happened at a small, type of incidents, but a major one, I think, will finally get the attention of everybody. Anybody else feel that's important?
The irony being, if it's an attack on an electrical system, nobody's computers will work to be able to fix them.
Yeah.
Well, Stephen, let me ask you this, since you live in a part of the world that has a few more regulations than maybe the rest of us. What is the role of government in trying to help drive some of this changes? Do they have a positive role to say, or is this going to be like, what Ronald Reagan used to refer to as the 9 most dangerous words in the English language? Hello, I'm here from the government and I'm here to help.
Oh, how do I answer that without opening up a whole bag of hot potatoes? You threw that one at me, didn't you? Yeah, I mean, obviously, government has got a massive part to play. In more than one sense of the word, it has a moral duty in terms of the safety of the population for which that government serves. For exactly the kind of scenario that Matt mentioned, that there's infrastructure within a country that we all rely upon. Interestingly, I spoke with one company last year who are dealing with operational technology, that they're dealing with OT, and they have devices which are connected to MRI scanners and X-ray machines and things like that, which provide security for those systems because they're not a computer-based system, they're not IT, but they are on a network and they are subject to potential hacking attacks. They're subject to attacks. We're talking about hospital equipment that people rely upon for their lives. And we need this kind of security in place to prevent people from blocking those out and preventing access to those. And that is a massive government responsibility in terms of the safety of its citizens. But there's also another aspect, which is disconcerting. We only have to look at many other countries that don't necessarily enjoy the freedoms that we do, where that security aspect is abused, where that is taken completely the other way. So just like as we've been talking here about how we implement security, and there's a balance with everything that we have to take into consideration, and that balance is also there in terms of our governments. There has to be the right checks and measures in place to ensure that what is being implemented doesn't impact upon our civil liberties, but also provides us with the protections that we need.
All right, Scott, I see that you're leaning in. You got something you want to add here?
I was trying to figure out how we went from AppSec to infrastructure, SCADA systems, security. Lots of good points. I just don't know how they're like connected together necessarily.
It's called that layer 7 stack. All dependent upon each other, right? At the end of the day.
Sure.
All right, guys. If there's one thing, Kyle, maybe we'll start with you. We only got 5 minutes left, so we got to keep it short. But what's the one thing you wish people were doing right now when you go visit and you talk to all these companies? What's that one thing that you go, boy, life would be easier if everybody just did X? You're on mute for some reason.
Sorry about that. My cat was crying like a baby. So basically what I would say is just like robust threat modeling exercises. I used to make like a card game. I would like create these different types of like threat actors, and I'd have a stack of like cards, and I'd laminate them, and I just sort of like cut them out. So different threat actors, right? Different types of vulnerabilities. And then we would sort of like go through these cards, and we'd say like, all right, who would be interested in this system based on the information that, we're storing in it, or based on what it's processing, or based on who we're delivering it to? Who would be interested in this? And we'd go through the cards, and we'd sort of play like a threat modeling game. I'm really big on the gamification. So I wish security teams would gamify their security exercises, make it engaging to developers, make it developer friendly. And I think, like Scott was saying, really, like, you need to present the feedback in a developer friendly way so that they're going to get it. And I think gamification and sort of integrating into that life cycle is a great way. I think whenever we had a security champion attend a sprint grooming session or a sprint planning session, the teams were actually pretty excited because they knew we were bringing that deck of cards. So I'd say gamify it, make it fun, make it engaging, and just do right by your developers. Nobody wants it to be boring. Hopefully you don't either.
All right, we got 3 minutes. Matt, what do you think?
My question is, do you really understand what's in your production environment? You're releasing 100,000 times a day. Do you know what services are in your application and what that application actually looks like? The concept of application architectural drift. Is it really what you think it is in the picture? I have a lot of presentations that talk about what you think is in production and what is actually in production. And without being able to know what's in production, how can you be, sure it's secure? So understanding what you're actually deploying, you're doing all these checks and balances, part of your CI/CD pipeline or your DevOps process, but is there a process in something getting into your production environment you don't know about? And then taking it one step further, everybody looks for known types of vulnerabilities, OWASP top 10, those type of things. What about the vulnerabilities that are specific to your application architecture? How do you find those? The things that are only unique to you, where no tool is configured to look for it.
All right, guys, I promised you an hour would fly by before you knew it, and lo and behold, here we are. I got to kick it back to Cody, who's going to take us out in a little bit, but I want to thank you all for sharing your knowledge and expertise, because I always learn something every time I do one of these things, so this is always great. Cody, take us out.
Awesome. Thank you, Mitch. So to Scott, Kyle, Stephen, Matt, and Mike, thank you so much for taking the time to join our discussion and share your expertise with us. I'd also like to quickly remind our audience that today's session was recorded. So following this session, you'll receive an email with a link to access this recording on demand. You can also find this webinar living on the Security Boulevard website at securityboulevard.com/webinars. So we do have those 4 Amazon gift cards to give away. It's for 4 $25 Amazon gift cards. Our first winner is Monique L. Our second winner is Rusty S. Our third winner is Abigail T. And our fourth and final winner is Masa N. So to the 4 of you, congratulations. Keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. So again, Scott, Kyle, Stephen, Matt, Mike, thank you so much for joining us today. I'd like to thank Security Boulevard for putting on this webinar. And my final thanks, as always, goes to you, our audience. We really appreciate the time that you take to be with us. Please, we just ask for one extra moment of your time to fill out a quick post-webinar survey. But otherwise, we hope to see you at an upcoming Techstrong Learning webinar. Everyone have a great rest of your day.